Bar stock, also colloquially known as billet, is a common form of raw purified metal, used by industry to manufacture metal parts and products. Process and types. Most metal produced by a steel mill or aluminium plant is formed into long continuous strips of various size and shape. These strips are cut at regular intervals and allowed to cool, each segment becoming a piece of bar stock. A good analogy is pasta making, in which lumps of dough are extruded into various cross-sectional shapes, cut into lengths, and then dried in that form. The cross-sectional shapes of pasta vary from simple bar or tube shapes to more elaborate extrusions. The same is true of metal bar stock. The most common shapes are round bar, rectangular bar, and hexagonal bar. Tube and pipe are similar, but have hollow centers and are traditionally not called bar in industrial usage. Also similar in concept, but not called bar, are the common structural shapes such as angle stock and channel stock. These are commonly available in steel and aluminum. The names angle iron and channel iron are still commonly used, even though the literal namesake, wrought iron, has been replaced by steel and aluminum for most uses. In a machine shop, bar stock and plate are often called billet, although in a rolling mill, that word refers to a piece of metal that has not yet been rolled into bar. A machine shop typically has a storage area containing a large variety of bar stock. To create a metal component, a bar of sufficient volume is selected from storage and brought to the machining area. This piece may then be sawed, milled, drilled, turned, or ground to remove material and create the final shape. In turning, for large diameter work, although there is no universal threshold, a piece of the bar is cut off using a horizontal bandsaw to create a blank for each part. The blanks are then fed into a chucking lathe which chucks each one in turn. For smaller diameter work, the entire length of bar stock is more often fed through the spindle of the lathe. The entire bar rotates with the spindle during the part machining cycle. When the cycle ends and one part is done, the chuck opens. The bar is pulled or pushed forward by any of various automatic means. The chuck closes, and the next cycle begins. The last step of the cycle is to cut off the machined part from the bar, which is called parting it off, and is achieved with a cut-off or part-off tool, a tool bit that grooves the bar all the way down to the center line, causing the part to fall off. Then the cycle repeats. The not yet cut bar protruding from the back of the spindle, rotating quickly, can present a safety hazard if it is sticking out too far and unconstrained from bending. Thus, sometimes long bars must be sawn into shorter bars before being fed as bar work. CNC lathes and screw machines have accessories called bar feeders, which hold, guide, and feed the bar as commanded by the CNC control. More advanced machines may have a bar loader, which holds multiple bars and feeds them one at a time into the bar feeder. Bar loaders are like magazines for part blanks in that they allow lights-out machining. The bar loader is filled with bars during working hours, and then it runs during the night unattended. Given that there is no human around to detect if something went wrong and the machine should stop, there are various kinds of sensors that are used to detect this, such as load meters, infrared beams, and, in recent years, webcams, which are placed inside the machine tool's enclosure and allow remote viewing of the cutting action. Standard sizes throughout a supply chain. To stock every possible size of bar stock is impossible. Thus, bar stock is stocked by metal supply houses in various standard sizes, arrayed in discrete steps. For example, round bar with diameters of even millimeters can usually be ordered from standing stock. Bar diameters of non-standard sizes can also be obtained, but only as a separate mill run from the rolling mill. Thus, they are much more expensive than the standard sizes, can take much longer delivery time, and are not desirable as inventory for the supply house of the machine shop. Sometimes it is necessary that the bar not be very much larger than the intended part, because the metallurgical properties of some metal alloys in some finishing processes may vary by how far inside the bar the metal lies. Thus, an engineering drawing will specify a certain size that the bar may start out as. These specs face the aforementioned limitation of stocking sizes versus custom mill runs. Standard sizes are used wherever possible to avoid wasted expense and needless delays. Drill rod. Drill rod is tool steel round stock ground to a tight tolerance diameter. It is usually plus or minus 0.0005 in. In the UK, the name silver steel is often synonymous and sometimes hyponymous. Its origin was in reference to the shiny ground appearance. Drill rod diameters range from 0.0135 to 1.5 in the United States. Diameters smaller than 27/64 of an inch are made in letter drill sizes and number drill sizes, in addition to fractional sizes. Lengths are usually 1 of 3 feet. It is commonly used to make drill bits, taps, reamers, punches, dowel pins, and shafts. Note that the numbered sizes are different from the drill numbered sizes starting at 52. These sizes are: drill blanks have an undersized tolerance of plus or minus 0.0002 in, while reamer blanks have an oversized tolerance of minus 0 plus 0.0002 in. Some mills also sell square stock that is held to the same tolerances under the name drill rod. Commonly available material grades in the U.S. are A2, D2, M2, M42, O1, S7, W1, and high-speed steel. Ground flat stock. Ground flat stock is annealed steel that has been ground to close tolerances. There are 4 types of materials available: O1 tool steel, A2 tool steel, A6 tool steel, and 1018 steel. Lengths are either 18 of 36 in long. Various widths up to 16 in are available, and thicknesses range from 1/64 to 2.875 in. Some geometrical sizes are known as gauge plate.